Okay, so this is a run through of the AQA November 2017 paper 1F foundation students. So basically we'll try and go through all the questions as best as we can. Right, so remember the way it works. Stop the video at any time, try the questions, and then you can just scroll through and listen to answers as and when you like. So we've got a circle decimal which has the same value as 3/5. Well, we should recognise that 1/5 is 0.2, so 3/5 will be 0.6. We can go through the answers and check. Yeah, there we go, 0.6. It says circle it, so that's fine. We could check, because this is in the hundredths column, then we know that's the equivalent of 6/100ths, which cancels down to 3/50ths. We know this is, again, the 5 is in the smallest place value of hundredths, so this is the same as 35/100ths, which cancels down to 7, because divide by 5, 7/20ths. And we can see that 3.5 is more than a whole and 3/5 is less than a whole, so we're fairly confident 0.6 will be the right answer. How many millimetres in 7.5 centimetres? Again, conversions, you need to know your facts, guys, so we should recognise from our rulers that 1 centimetre is the same as 10 millimetres. So 7.5 centimetres we would times by 7.5 to get 1 up to 7.5, and 10 times 7.5 is 75. Remember, this is a non-calculator paper, so we have to try and do everything without a calculator. So we can see here that 75 would be the correct answer. Which of these shapes has 2 lines of symmetry? Well, again, we should be thinking about lines of symmetry. So if we think about a shape, take a square for argument's sake, then we know all the lengths are equal, and it has 4 lines of symmetry, and a line of symmetry cuts the shape in half such that both halves will fold over each other and fit exactly, so they're congruent. So another line of symmetry down there, another line of symmetry down there, and another diagonal line of symmetry there. So 4 lines of symmetry on a square. This one wants 2 lines of symmetry. Well, a semicircle we recognise, sketch a picture to help ourselves, 1 line of symmetry. A rhombus we can see has a line of symmetry down there and a line of symmetry down there. Trapezium, lots of types of trapezium, so be careful that we're thinking about all of them. If it's an isosceles trapezium, then you could have 1 line of symmetry, but generally a trapezium may not have any lines of symmetry. It depends whether it's a special one. And an isosceles triangle, then we recognise has 2 sides the same length and just 1 line of symmetry. So it has to be the rhombus. Okay. Circle the number that is 7 less than -12. Well, again, we should always have in mind our number line, so we know -12 is there, below 0. If we go this way, we're getting bigger, so we're adding, and if we're going this way, we're subtracting. So in other words, we're getting less, so if we're getting less, we'll be counting down even further. So if we're counting down 7, then we're going to get to -19. So it's going to be -19. Solve means find the value of x that makes this statement true. Something take away 3 is 14. Well, we either recognise that 17 take away 3 is 14, so we can finish off by saying x is 17, or we can add 3 to both sides, and therefore we'd end up with x is equal to 17. This one, solve. Again, we've got to think to ourselves, what does that mean? Well, it's telling us that we're doing 5 times y is 45, so we're looking for something in the 5 times table, that's 45. So we either know that 5 times 9 is 45, or we can take the 5y equals 45 and we can divide both sides by 5, and in doing that then we've made this true, and divide by 5 leaves us with 1y, and divide that by 5 we get 9. So we end up with y equal to 9. Again, we should check, because the idea of solving is to find a value for the letter, and then we can check that it works, and 5 times 9 just gives us 45. And this last one on the solve, we want to do 8 plus something gives us 6, so if we take away 8 from both sides, then we can find what w is, because 8 take away 8 is 0, so we're left with w on this side, and 6 take away 8 is -2. Again, if you're not sure, I think what happens here, we are taking away 8. So to get to 0, we take away 6. So we need to take away 2 more, and we'd go down to -2. So that's how those could be answered. So here we've got work out 9,174 divided by 11. Lots of techniques to do this, but classically we draw out this diagram, fill in our numbers, and then do the division. So we end up doing 11s into 9. It's not going to work, so put a 0, carry the remainder. Now in here you always carry the remainders over, and the remainder from 11 into 9 is 9, because we haven't used it yet. Now we're saying 11s into 91, so we go through our 11 times table, and we can see that 11 eighths is 88. So that's going to be 8, and if we take 88 away from 91, we're left with 3, so that's our remainder, so we carry the 3 over. We can see that 11 times 3 is 33, so 11s into 37 is going to be 3. 37 take away 33 is 4, so we're left with 4. That's the remainder, so we carry it over to the next digit in the number. And 11s into 44, well, we can see that 11 fours is 44, so that's going to be 4. So we think the answer is going to be 8, 3, 4. We should do a rough check and just make sure that we're okay. So if we do 830 times 10, we get 8,300, and if we add another 830 to do 11 of them, then we recognise 0, 3, 1, 9. So it's roughly around the answer we expect, so it's not 834 seems reasonable. Work out this addition of fractions, and we got to notice here they want the answer as a mixed number. So we must remember a mixed number looks like a whole number with a fraction part. So that's normally what we want the answer to look like. Work out means find the value, so we've got to do this. And when we're adding fractions, we've got to remember that we need a common denominator, which is normally the lowest common multiple. So we're going to make 6 and 7ths both 40 seconds, because we know that 6 is going to 42 and 7 is going to 42. So 5/6 make it equivalent to something 42s. Well, we have to times the denominator by 7, so we have to times the numerator by 7. So that's going to be 35, and then we know that 3/7 is going to be turned into equivalent of 40 seconds, so we have to times by 6. So we end up with 18, and then we finish off the calculation we have to do. So we have 35 40 seconds, which is the same as 5/6, plus 18 42s 40 seconds, which is the same as 3/7. Because we're dealing with 40 seconds, the answer is going to be 40 seconds, but we've got 35, 45, 53. So that gets us 2 marks, but then we remember the question says give the answer as a mixed number. So here we have to think to ourselves, well, a whole one is the equivalent to 42 40 seconds. 42 divided by 42 is 1. So if we take 42 40 seconds out of here, then we're left with 11 of them. So this is equivalent to 1 and 11 40 seconds. Do a quick check. The 1 is 42 40 seconds plus 11 40 seconds, then we know that's 53 40 seconds, so that's going to work. Okay, so the answer here then would be 53 40 seconds. Okay, so this is a diagram showing us information, and it shows the scores, so we underline that it's important. During a television show, so it's about scores. So basically we've got to recognise that this bar here is saying that 9 times, because frequency means how often, total. So 9 times 4 was scored, and so forth. So go through the question, which score was the mode? Well, we've got to remember the mode is the most often, highest frequency, so in other words the one that occurs the most. So when we look at our line graph, we can see, or line chart, we can see that our highest frequency was here, 9, and I had a score of 4. It said which score, so we got to say the score was 4. The question goes on and it says that there are 4 judges. Each judge gave 1 score in each round. How many rounds were there? Okay, so we've got to work out the total frequencies, because that will tell us how many scores were given, and then we can divide that by 4 to see how many rounds there were. So we know this one is representing 3 scores. This score was given 6 times. This score was also given 6 times. This score was given 9 times, and this score was given 4 times. So if we add up those, 3 plus 6 plus 6 plus 9 plus 4, 9, 15, 24, 28. So there were 28 scores, and if we do 28 divided by 4, it tells us there were 7 rounds. Okay, so that's how that question could have been done, because we recognise from the bar line graph that there were 28 scores given altogether, and because there were 4 judges giving scores, then divide that by 4, we get there were 7 rounds. Okay, so a library book was due to be returned on the 27th of September. It was actually returned on the 14th of October. There's a fine of 8p for every day. Okay, work out the total fine. Okay, so it was late on the 28th of September, the 29th, the 30th, and really to our months. So after the 30th there is no 31st. If we don't know it, then the knuckles can help us with this. January, February, March, April, May, June, July, August, September, October, November, December. Every knuckle is worth 31 days. So January, March, May, June, July, August, September, October, November, December. So all of those months have 31 days. Anything in between has 30, except February, which has 28, except in a leap year has 29. Okay, so 1st of October, right, through to the 14th of October. So we can see there was 1 day, 2 days, 3 days, plus 14, so there were 17 days late, and it was 8p for every day. So we have to do 17 times 8. 7 times 8 is 56, and 1 times 8 is 8, plus the 5 is 13. So that's pence, and it wants the answer in pounds, so we have to divide by 100 pence in a pound, so we end up with £1.36. Okay, so we work out the total fine, then we know these were the days late, so it was 17 days late. Okay, so in a game 3 stars are hidden at random, so each star is behind a different square on the board. So we can see there was 5 squares by 5 squares, so first thing we need to know is there are 25 squares. Okay, a square is chosen at random, so that's 1 out of the 25. What is the probability that there's a star behind it? Well, if there were 25 squares, then the probability is 1 out of... actually, we'll read the question carefully. There were 3 stars, so it's 3 out of 25, because 3 of those squares have a star, 25 to choose from, so 3 25ths. Okay, so in one game the stars are behind 3 consecutive squares. The squares are in 1 row or 1 column. One of the squares is E2. Okay, so help ourselves by adding it onto the diagram. So we know that the star could have been there. Sorry, my drawing skills are never brilliant. Okay, so they're either in 1 row, so that means they could have been along there, or in 1 column, so that means they could have been along there. So basically we know it's 3 consecutive, 3 consecutive. One of the squares is E2. Write down all the possible pairs for the other 2 squares. Okay, so we could have been in C2, D2, E1, E3. Okay, so that's what that one wanted. So just using grids. just check. Yep. Okay, so here we've got to complete a table to show equivalent fractions and percentages. Alright, so I basically remember that a half is equivalent to 0.5 is equivalent to 50%, and I know to get from there to there I times by 100, I know to get from there to there I divide by 100, and I know to get from there to there, then I always think what the decimal looks like and ask myself what's the smallest place value. So in here we can see 5 is in the tenths column, so it's equivalent to 5 tenths, which is equal to 1/2. So when I do other ones, and to get from there to there, I do 1 divided by 2, so 2's into 1, 0, remainder of 1 carried over, 2's into 10 is 5. So there's lots of ways of getting from fractions to decimals to percentages, but if I remember what I did with this one, then if I want to do 3/8, it's the same idea. You know, I would do 8's into 3 to get the decimal, so 0 points, carry the 3 over, so 8's into 33 remains 6, 8's into 67 remained 4, 8's into 45, so it'd be 0.375, and then I can times up by 100 to get the percentage, 37.5%, and so forth. So, you know, that's a technique for remembering these things if you don't want to remember all of them individually. So 3 tenths, well, we either recognise that 1/10 is 10%, and then we know that 3 tenths would be 30%, or I can go through the process of doing 10s into 3, 10s into 3, so carry the 3 over, 10s into 30 is 3, so 0.3, times that by 100, get the percentage. 43% into a fraction, well, if we go backwards, then we're going to do 43 divided by 100 is 43 over 100th, and doesn't cancel down because 43 is a prime number, and 100 is like the 43 times table, so that stays as that. 5 divided by 2 as a percentage, well, if I do 5 divided by 2, then 2's into 5 is 2, 1 over, 2's into 10 is 5, so 2.5. If I then times that by 100, I can get the percentage, which is 250%. So that'll be 250%. Okay, so that's a way of doing those kind of questions. Okay, so cards in a pack. Alright, so we need to remember that there's 52 cards in a pack. Okay, so cards in a pack are red and blue. What fraction of cards are red? Actually, we don't need to know that because it's not about a standard pack of cards, so apologies for that. Cards in a pack are red and blue, the ratio. So for every two red, there are 3 blue. That's what that ratio means. So again, we need to understand what the question is talking about. What fraction of the cards are red? So we know what a fraction looks like. 2 numbers over. So for every 5 cards, so for every 5 cards, 2/5 are red, 3/5 are blue. Okay, so what fraction of cards are red? Well, 2/5. A different pack has 72 cards. 5/9 are yellow. Work out the number of yellow cards. Okay, so the question is then saying to us to do 5/9 of 72. Lots of ways of doing this, but lots of people remember that if you find a 9th first, so we do 72 divided by 9 is 8. That tells us what 1/9 is, and then we times by 5 to get 5/9. And if we do 8 times 5, we get 40. So the answer here will be 40. Okay, so that's a way of doing those. Okay, how many edges? Okay, so we've got to remember that edges are the bits that join vertices. So between 2 vertices is an edge and a shape. And it says on a square base pyramid, so again we've got to know our shapes. So if it's got a square base, then we recognise it's going to be that. Pyramids always go to an apex, a point. So basically a square base pyramid will look something like that. And we've got to recognise then that there are 1, 2, 3, 4 edges on the bottom face, and there are 4 edges going up to the apex, so therefore there'll be 8 altogether. So there'll be 8 edges there. How many faces? Well, we've got to remember that faces are the 2D shapes that make up the 3D. So that's a face of a cuboid, that's a face, and that's a face. So they're the shapes that make up the 3D image. So we've got a triangular prism, so we've got to remember that a triangular prism means a shape that starts off as a triangle, it's extended parallel, and it ends up with the same triangle at the other end. So a triangular prism. It says how many faces of a triangular prism are triangles? Well, we can see from a triangular prism there is 2 faces that are triangles. Okay, got to learn our shapes. Okay, next question. A bus can be early, on time, or late. The probability that the bus is early is 0.1. The probability that the bus is on time is 0.6. Work out the probability that the bus is late. Okay, so each of these are what's called mutually exclusive. The bus can't be early and late at the same time, so they're mutually exclusive, which means that all probabilities will sum to 1. So all known probabilities, it's actually all known outcomes will have a probability total of 1. So in other words, 0.1 plus 0.6 plus our question mark for probability of late must equal 1. Well, if we add those we get 0.7. So our question mark should be 0.3. That's 1, take away the 0.7. So the answer here will be 0.3. Okay, so when you've got mutually exclusive outcomes, in other words things that can't happen at the same time, then all the probabilities will add up to 1 for all known outcomes, or all the possible outcomes. So early on time, 0.7 altogether, so the late must be the rest to 1, 0.3. Okay, so here we've got a question that says draw a graph, so we must make sure that okay, so try to find my ruler. Alright, don't seem to have it, never mind. Okay, so on the grid we've got to draw the graph of x plus y equals 2. So to draw a graph we need coordinates. And to draw a graph that we know is going to be a straight line, because these are power 1, so it's going to be a linear graph, then we know that we're going to need 3 coordinates. So if we choose some simple coordinates for x and y, so if we choose 0, and that means y must have been 2, and if we choose 1 then we know that y must be 1, and if we choose 2 then y will be 0. So these have given us the coordinates 0, 2, 1, 1 and 2, 0. Basically we're making sure that the x and y values both add up to 2. So those are the coordinates that we plot, so 0, 2. So first coordinate is always the x number, second coordinate always the y number, so we go to 0 on x, then up to 2 on y, go to 1 on x, go up to 1, go to 2 on x, go up to 0, which means stay there, and then we draw the straight line between them. So, okay, for some reason I don't have my ruler at hand. Whoops. Okay, so let's make a quick ruler. Alright, so we then get our thing. Now as it said it's got to go from -3 to +3, then we make sure that we do that. So we draw so that the graph covers from -3 across to +3. Okay, so that's how we can draw a graph by working out some coordinates, and then we can plot them. Okay, so this is a little puzzle. 5% of a number is 31, 1% of the same number is 6.2, work out 13% of the number. Alright, so we've got lots of ways of doing this. We could work out what the number was originally, because if we know 5% is 31, then we know there's 25% in the whole, so we could do 20 of that, and then do 13% straight away with that, or we could recognise that these could be made up to 13%. So we know that 5% plus another 5% plus 1%, 1% and 1%, if we add all those together we get 13%. So if we take 31, 31, 6.2, 6.2, 6.2, add all those together, then we'll get the 13% of the same number. So we got 0.2s, so we got 2, 2, 2, that's 6, that's the points dealt with. 1, 2, 8, 14, 20, 30, 60, 80. So 80.6. If we want to do a check, then 100% would be 20 times 31. 2 31s is 62, and we've got a times by 10 in there, so 620. And if we want to do 13%, then 13% is the same as 0.13. So 0.13 times 620. 62 times 13 is 62 times 10, and 62 times 3, 186. Add those together, 7,806, and then turn that into a decimal, so it's going to be 80.6. So as a check, we can check that it worked. Okay, so 80.6 will be the answer for that question. Okay, so we're going to complete this grid so that when we multiply the three numbers in any column, the answer is 1. Okay, so column, row or diagonal. So we recognise what's going on here. Then if we do this one down here, we're doing 10 times 2, which is 20, and 1/20 of 20 equals 1. So basically you're trying to make sure that all three of them, when they're multiplied, give you an answer of 1. So we can see going along here that 2 times 5 is 10, and to turn 10 into 1 we'd have to multiply by 1/10. We can check that works. A half of 20 is 10, times that by 1/10 is 1. A half of 10 is 5, but I want to make that 1, so we have to take a fifth of it. A fifth of 5 is 1, and I want to turn that into that, so I need 1 in there. So let's just check. 2 times 1 is 2, times a half is 1, 10 times 1 is 10, times a tenth is 1, 20 times 1 is 20th, yep, so that's how it all works. So we have to just make sure that everything multiplies to give us 1. So if we want to just see how this works, 10 times a half, well that's the same as saying a half of 10, which is 5. And 1/5 times 5, well the 5 is a fraction really, it's 5/1, and then when we multiply fractions we do 5 times 1 is 5, and 5 divided by 5 equals 1. So our check kind of works. Okay, so this next one is a term-to-term rule for a sequence, and has 3 terms. And the term-to-term rule, so we've got to multiply by 8 and then add 11. It says the first term of the sequence is -1. So we've got to multiply by 8, which is -8, and then we've got to add 11, which is going to be +3. That's going to be the second term. The third term, well, we're going to take the number 3, multiply by 8, which is 24, and then we're going to add 11 to that, which is 35. So our sequence then, so it says work out the third term, so we worked it out to be 35. The order of the 3 terms is reversed to make a new sequence. Okay, so we've got 35, that's going to go to 3, and then that's going to go to -1. That's what they mean by that. Work out the term-to-term rule for this sequence. So in other words, we've got to reverse the rule. So instead of adding 11, we take away 11. So we subtract 11, and instead of multiplying by 8, we divide by 8. Then divide by 8. Okay, let's just check that works. So we do 35 subtract 11, which is 24, and then we do 24 divided by 3, which is 8. No, divide by 8, sorry, 24 divided by 8, which is 3. Yep, so that works. Okay, so that's how that question was wanted to be done. Okay, so this question is looking at angles. It says ABCD is a quadrilateral, so we know that means 4 sides, and the sides are extended. Okay, so we can see angles going on here. So we know that this angle here is also going to be 70 degrees because vertically opposite angles are equal. We can see a right angle here, so add things onto pictures to help yourself do the question. And we can see that this angle here is going to be, well, a quadrilateral, all the interior angles add up to 360. So we know this is going to be 360, take away 120, take away 90, take away 70. So we know that's what's happening with this question. And if we do 360, take away 120 is 240. Take away 90, 150, take away 70, 80 degrees. So we know that this is 80 degrees, add things onto the picture. And we know that angles that meet at a point on a straight line add to 180 degrees. So x is going to be equal to 180 degrees minus 80 degrees, which equals 100 degrees. And that's what the question wanted us to show. So that's that question done. Okay, so we've been told that 2 gallons is equivalent to 9 litres, and we've got to convert 17 gallons into litres. So 17 gallons divided by 2 is 8.5, so we've got 8.5 lots of 9 litres. So we do 9 times 8.5, so 9 5s are 45, 5 down, 4 over, decimal point, 9 8s are 72, add the 4, 76, so 76.5 litres. Okay, so what we did here is, if we want to convert 17 gallons, then we divide by 2 to find out how many lots of 9 litres we have. That's one way of doing it. We could have found that 1 gallon is, so as a check, we could say 1 gallon equals 4.5 litres, and then we could do 17 times 4.5. Okay, so a little bit harder, a little bit longer, but should give us the same answer. So 7 5s are 35, 3 over, 1 5 is 5 plus the 3 is 8, and then we've got to do the next, so 0, moved across place values, so put a 0 down, 7 4s are 28, so 8 and 2 over, 1 4 is 4 plus the 2 is 6, so we now add those together, so 5, 6 and 1, 6 and 1 makes 7, decimal point 76.5. So again, it didn't matter which way around we did it, we got the same answer, 76.5. Okay, so n is an odd number, so 1, 3, 5, 7, 9, 11, etc. P is a prime number, so the first prime number being 2, because prime numbers, remember, are only numbers that have 2 factors, so they divide by 1 of themselves. So 2, 3, 5, 7, 11, etc. In each part, write down possible values of n and p so that n and p is a square number. So again, we should know our square numbers. Square numbers are the answer to multiplying whole numbers by themselves. So square numbers go 1, 4, 9, 16, 25, 36 and so on. So the answer to 6 times 6, etc. So we want n and p, so we've got to find numbers from this list that add together to give us one of these answers. Okay, so we can see 9 and 7, for example, they add together to give us 16, so 9 plus 7 equals 16, so n could be 9 and p could be 7. We could have had 1 and 3, which gives us 4, So you could have had lots of combinations there to give you that. And here it's saying that NP is a square number. So in other words, we need to do n number times a p number, and it gives us one of the square numbers. So when we look at this, we can see 5 times 5 is 25, and that is a square number. So 5 times 5 equals 25, and 25 is a square number, so n could be 5 and p could be 5. Okay, so again we've got to learn our facts, guys, and writing a few down helps us to see what we're doing. So that's one way of doing that question. Okay, so Joe wants to bisect angle BCD. Bisects cut in half. So this is part of the loci work, and what we should remember is that we would take our pair of compasses, we would draw an arc through both the lines, we would then put our compasses there and draw an arc, put our compasses there, draw the arc, and where they cross we'll bisect the angle. So here is his method. He uses a pair of compasses to draw the arc. Arcs of the same radius from B and D. Draw a straight line through the intersection, write down the error. Okay. Alright. Basically, he needs to draw a common arc through CB and CD first, then draw arcs from these points where the arc crossed CB and CD. Okay, so basically we should have a common point there and a common point there, and then draw the arc through them. Okay, so that's how that one could have been done. Okay, so K wants to show all the points 3 kilometers from that. 1 centimeter represents 1 kilometer, so we know that 3 kilometers is going to be represented by 3 centimeters. If it's all the points from one point, then from a single point, then all the points that are a circle around that point will be the same distance away, just the radius. So basically this means get your compass, open it up 3 centimeters and draw the circle. Now I don't have my compasses with me, but basically it's about drawing a circle 3 centimeters radius. What is wrong with our answer? So basically we know that the question wants us to draw a circle around here. What is wrong with our answer? This is more than 3 centimeters. Needed a circle around point P. Okay, so when the question says what's wrong with our answer, then basically we know that we're drawing a circle, not that. So that diagonal there from the centre there to there is more than 3 centimeters. So that was wrong with that. Use a pair of compasses and a straight edge, construct one line of symmetry, showing clearly your construction arcs. Okay, so I don't think I've got any compasses quickly at hand. Nope, I haven't. Okay, I'll just talk you through that. Alright, so use a pair of compasses and a straight edge, construct one line of symmetry, show clearly. Right, okay, so we know the line of symmetry from a rectangle. So basically this question says it's a rectangle. So we know from a rectangle that line of symmetry can either be down there or across there. So we can draw either of those. Because we want to go between 2 points here and get the exact centre, it's telling us to use a pair of compasses, so we have to do this with compasses. We basically have 2 fixed points, and if you want to draw the line that's in the middle of 2 fixed points, you draw a perpendicular bisector. So this question is telling us to draw a perpendicular bisector. Now to draw a perpendicular bisector, you open your compasses, so you open compasses over half the distance between 2 points. Okay, and you draw so we're going to draw an arc that's going to do something like that. We then turn our compasses around and we draw the opposite arc, and we then draw the line between them. Now, have we done that properly? Because I'm demonstrating this, but when you draw this properly with compasses, guys, it will be exactly halfway, and then you repeat on this side, and then you literally just draw your line that's halfway between. Okay, so sorry I don't have any compasses with me, but that's the way you do it. So open your compasses over half the distance, put the compass point down there, draw the arc, turn your compasses around, keeping the same distance between your compasses, draw the arc that crosses, and where they cross, you draw the line between them, and that cuts this side exactly in half. And do the same the other side. Okay, so next question, ratio. Alright, so we've got to work out the value of x take away y. So we've been told that x to y is 7 to 4. So this tells me that x divided by y is 7 over 4. So if I multiply by 4, then I know that 4x's are the same as 7y's, or I know that x is equal to 7/4 of y. So lots of different ways of doing these kind of questions, but usually if you turn them into fraction equivalents, then it could help you to substitute. So here we know solving an equation, I need just one letter, so we can't have x and y, we need to have a single letter. So I'm going to replace the x with what I know here. So I know that 7/4 of y plus a y is equal to 88. If I multiply everything by 4, then it just makes it a little bit easier to work. So 7y plus 4y equals, well, 4 88s is 320, 352. So we know 11y's is equal to 352. So y will equal, well, if we do 11s into 352, 11s into 35 is 3 remainder 2. 3 11s are 33, and 11s is 32. So we know that y is 32. Check that, 10 32s is 320, plus another 32 is 352. So x, because we were told that x plus y is 88, is 88 take away 32. So that will be 56. So we know that's going to be, because it wants us to do x take away y. So let's do 56 take away 32, which equals 24. Okay, so that's one way of doing that. We could have also recognised that here we've got a ratio of 7 to 4, so altogether we're working with 11 parts altogether, and 11 to 88 is times 8, so I could have multiplied both of these by 8. So I just show that alternative way of thinking of this. So x to y, 7 to 4. If I multiply by 8, then I get 56 and 32. That gives me 88. This gave me 11. So we know this is kind of an alternative way to do equivalent fractions. And then 56 take away 32, same idea, 24. So there's several ways that you could think of that particular problem. But this link here is usually one good way to get it straight away. Okay, so we've got a distance time graph here, and it's talking about an Il's home is 1 kilometre from a shop. Okay, so this means the shop was there. He walked from home to the shop, okay, at a constant speed in 10 minutes. Okay. He stayed at the shop for 5 minutes. He walked home at a constant speed in 8 minutes. Okay, so this will be 23 because I was started at 15. So we're thinking through the information. All drew is distance time graph to represent his journey. Boom, boom, boom. Right, okay. So straight line on a distance time graph represents constant speed. A curve represents acceleration or deceleration. Okay. Right, so distance from home 2 kilometers. Okay. Alright, so that's the shop. This is home. So we've added things onto the diagram to kind of help us see what's going on, which is useful. Criticism 1. First part of graph does not show a constant speed. Should be a straight line. Criticism 2 is if you went to the shop and then home, then the graph should have finished down here. Okay, so graph should have gone back to 23, 0 as he went home, not another kilometre away from home. Okay, so those were the two criticisms. So we had the information, and then we had to think about what the graph was telling us and how we interpret distance time graphs, and then we had to criticise them. Okay, so 3 whole numbers, each rounded to the nearest 10. Okay, so we've got to remember what that means. If I've got 23, then that would round to 20. If I had 35, then that would round to 40. So nearest 10. The sum of the rounded numbers is 70. Work out the maximum possible sum for the original 3 numbers. Okay, so the sum of the rounded numbers is 70. Okay. Alright. So if I had 9, it would round to 10. If I had 29, it would round to 30. And I've got 40 so far, so I could have 29 again. That would give me 30. Alright, so that's one way of making 70. Okay, so let's look at different ways. So each of the numbers round to the nearest 10. Okay. So I could have had 0, 10 and 60. I could have had 10, 10 and 50. I could have had 10, 20 and 40. I could have had 20, 30 and 20. Okay, okay, let's have a look then. So the biggest number that would have been rounded down to would have been 4, 10 would have been 9, and 60 would have been 59. So this gives me a total of 68, 72. 68, 72, yeah. This gave me a total of 40, 58, 67. Okay, this would give me a total of 9, 9 and 49. Okay, so that's 18, 58, 67. Okay, and this would have been 9, 19 and 39. So 28, 58, 67. This goes right. 18, 27, 57, 67, yep. 19, 29, 19. So 38, 58, 67. Okay, so work out the maximum possible sum for the original 3 numbers. Okay, well, 3 whole numbers are rounded to the nearest 10. Do you consider 0? 4 is a whole number. Rounded to the nearest 10 would be 0. 9 to the nearest 10. Yep, 59, so 72. So I think the answer is 72. Okie dokie. Alright, so circle the expression for the range of n consecutive integers. N consecutive integers. For the range of n consecutive integers. Okay, so range means the maximum number minus the minimum number, the smallest number. So I've got n consecutive numbers, then if I had 4 numbers, n consecutive, they might have gone 1, 2, 3, 4, but then it's going all the way to n. So if I want to do the range, n take away 1. But if my consecutive integers started at 2, then I would have ended up doing n plus 1 take away 2, which would have given me n take away 1. Okay, so I think it's n take away 1, because you're always going to be taking away. So if I started at 2 and I had n consecutive integers, then I'd end up at n plus 1. N plus 1 take away 2 equals n take away 1. Yep, so n take away 1. Okay, so we've got 3 identical isosceles triangles that join to make a trapezium. Okay, so we recognise a trapezium, 4-sided shape with 1 pair of parallel sides, and we have a perpendicular height between them. And it's telling us that it's made of isosceles triangles, so we recognise isosceles triangles, those two are the same length, and it's saying each triangle has a base of b, so we know that's b, we know that's b, and has a perpendicular height of h. Okay, so we've got the information sorted. We know we can add things to the picture to help us. It says work out an expression, so that just means a series of letters with no equals at the end of it. Letters and numbers, of course, expressions. In terms of B and H for the area of the trapezium. Okay, so because it wants the area, then we've got to recognise the formula for the area of a trapezium is a half the sum of the parallel sides times the distance between them, the perpendicular distance between them. So we know from our picture of a trapezium that the parallel sides will be labelled A and B, and the perpendicular distance between them in H. Right, okay. So we know that length is B, and we know this is that. So we know the area equals a half of B plus 2B times H. Okay, so that's going to be a half of 3B H. Well, a half of 3B is 1.5, so that's going to be 3 over 2B H. So it'll be 3 over 2BH. Okay, so that's how that question could be done. Okay, so in this diagram shows the same trapezium. So we know that's B, we know that's B. Okay, it wants the perimeter. Alright, so because we know that that angle is equal to that angle, because it's isosceles, then we have an isosceles trapezium. Isosceles trapezium. Therefore, this is also S. Okay, same length between them. So work out an expression for the perimeter. Alright, so perimeter means add up all the lengths around the outside. So add up the edge lengths. Not necessarily outside, it's just the edge lengths you've got to add together. So we know that B to S is 2 to 3. We want to, in terms of B only. Okay, so B to S is 2 to 3. 2 to 3. So that means B over S is equal to 2 over 3. So S is equal to, so we times the 3 across and we divide by the 2. So S, so we times by S, that gives me B equals 2/3 of S. And then we times by 3, divide by 2. So that gives me S is equal to 3B over 2. Alright, so if we want the perimeter then, so the perimeter is going to equal b plus 3b over 2 plus b plus b plus 3b over 2. Okay, so we've got 1.5b plus another 1.5b is 3b plus the other 3b's makes 6b altogether. So the answer here will be 6b. Okay, so got to be careful with ratios, guys, and this idea that when we've got a ratio, they can be written as equivalent fractions. So b over s must be 2/3, and then we can rearrange that to find out what b is in terms of s. And that makes sense because b must be 2/3 of s, because if I do 2/3 of 3, I get 2. So it works like that. Okay, so here we've got a quarter circle of radius 6 centimeters. Work out the area. So we know the area of a circle where the radius goes from the centre to the circumference. So we know that the area is equal to pi r squared. If we've all listened to our circle song, then we'll know pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. So it says give your answer in terms of pi. So that means we want our answer left with pi. We don't multiply by its equivalent 3.14 and so forth. Okay, so do we know the radius? Yep, we know the radius is equal to 6 centimeters. We want a quarter circle. So because we want a quarter circle, then the area will be the full circle divided by 4. Okay, so we have pi times 6 squared divided by 4. Well, we know 6 squared is 36, so that's 36 pi divided by 4, and 36 divided by 4 is 9, so the answer will be 9 pi. Okay, so it said leave the answer in terms of pi, so that just means so many pi's, and we've got 9 of them because of the way the question worked. Okay, so we see in this question the word standard form, so we should remember that standard form numbers always start with a number that's less than 10 but greater than or equal to 1, and then it's followed by a power of 10 to tell us where the place value of the largest value digit is. So we can see in this number, if we write it out a bit bigger we can see what's going on. Then our units column is always the 10 to the power of 0 column, because 10 to the power of 0 equals 1. Our tens column is 10 to the power of 1, because 10 to the power of 1 is just 10. Our hundreds column is 10 squared, so 10 hundred. Our thousands column is 10 cubed, 10 to the power of 3. And our 10,000s column is 10 to the power of 4. So our highest power digit is 10 to the power of 4, and that's 1. So it's going to be 1.25 times 10 to the power of 4. Just find where the highest power is in the number, and that then gives you the times 10 bit, and then the number at the front always goes 1 point something, 2 point something, 3 point something, something like that. So we've got to write this as an ordinary number. So if we think about our place values, then the units column is always 10 to the power of 0, followed by our tenths column, which is 10 to the power of negative 1, 10 to the power of negative 2. This is saying 3.4 times 10 to the power of negative 2, so the 3 was in the 10 to the minus 2, or 10 to the negative 2 column. So there must have been another one, followed by the 4, and everything else gets filled in with 0, so write the number properly. So it'll be 0.034. Okay, so again it's about the highest place value digit in the number, and then find its place value and then write the digits accordingly. So we've got to work out the value of the root of 3 squared times the root of 2 squared. Well, if I multiply 2 square roots, then it basically is going to be written as 1 square root by putting the 2 numbers inside as a multiplication. So this is saying the root of 9, which is equal to positive or negative 3, but in terms of this question it'll be working out the positive values. If we square a square root, it cancels the square root out basically, and we're left with the number inside the square root. So this becomes 3, this becomes 2, so the answer will be 6. Okay, so that's how that question worked. Alright, so we've got a question here that involves a pie chart. So we know that the angles in a pie chart all add to, so all angles for each sector add to 360 degrees. Pie chart shows a proportion, so a fraction, in this case fraction of the circle. Kind of work out the probability, so we know that the probability is going to look like a fraction. Okay, and because it's about a pie chart, then it's going to be out of 360 degrees. Because it's about proportion, then the angle represents the proportion. And we want voted C. So we can see here they've been nice to us. They've told us this is about x's, so that means we're going to create an equation. We know this angle here is 90 degrees, so our equation is going to be, when we add up all the angles, we know it's going to equal 360 degrees. So 2x plus 10 plus 2x is going to equal 360 degrees. So if we add these up, then we've got 3x's, 5x's, so we know that 5x's, and then we've got plus 100 degrees equals 360 degrees. So if we subtract 100 degrees from both sides of the equals when we're solving, so 5x's are going to be worth 260 degrees, and we want x, so we divide by 5. Dividing by 5, divide by 10 first, and then double back. So if I divide 260 by 10, I get 26, and I double back, I get 52. So x is worth 52 degrees. Now it wanted the c, so when I go back in here, I know the x was 52 degrees, so it'll be 2 times 52 plus 10. Bidma says I do the multiplication first, so that's going to be 104 plus 10, 114 degrees. So our probability then is going to be 114 out of 360 degrees. Because it's a proportion, then the angle represents the proportion. We could cancel that down if we wanted to, so 57 over 180 degrees. We could recognise both of these divide by 3, so 57 divided by 3 is 19/60th. If you'd have left the answer as that, that's fine, because the question wanted a probability, and fraction answers fine, not cancelled down for probability. Okay, just check, didn't say simplest form or anything, no, that's fine. So that's how that question could have been done. Okay, so we've got some inequalities to solve, and we've got to factorise. Right, so factorise says we're going to put into brackets. When we look at this here, we can see that this has got no common factor apart from 1, so therefore it's going to be 2 brackets. Okay, there's no x's in there, so I can't take x out as a factor, and there's only the number 1 there. So that has highest common factor 1, and this has highest common factor 1 when you deal with the number of parts. When it's highest common factor 1 in an expression, then it factorises to 2 brackets, if it's going to factorise at all. So we know it's going to be 2 brackets. This is actually one of the special ones. It's known as the difference of 2 squares. So in other words, both brackets have the same answer, and if you square root both things, then you'll find out what goes in the brackets. So it's x and 10, one's a plus and one's a minus. That's the special property of the difference of 2 squares. So if you have a squared, take away b squared, it's equivalent to a plus b times a minus b. Okay, so factorising. If you don't know that technique, then you could have gone through the grid approach, where we could put our x squared there, our 100 there, and we know that these have got to add to equal 0 x's, because there's 0 x's in this expression, although it's a quadratic. We know this is a timesing grid, so to make x squared we know we need x and x. To make 100, because we know it's about squaring, then it's going to be 10 and 10, and because we want to make 0, then one of them's got to be a plus and one of them's got to be a minus. And then this will give us negative 10x, this will give us positive 10x, and 10x take away 10x is 0 x's, and we've got x squared, and 10 times negative 10 is negative 100. Sorry, I should have negative 100 there to remind us that we had to have a negative and a positive. Okay, so that's how that could be done. Solve this. Solve means find the inequality. We know it's an inequality, so we know our answer's got to have that symbol in it. So we're going to take away 2x from both sides, which will give us 5x plus 6 is greater than 1. 2x take away 2x is 0, so gone from that side. 7x take away 2x is 5x. We're then going to take away 6 from both sides, so we end up with 5x is greater than negative 5. We want 1x, so we divide by 5, so x has got to be greater than -1. So x has got to be greater than -1. We should check that that works, so x is equal to -2, that's less than -1, so this should fail. So if we put -2 in here, then we end up with -14 plus 6, which is -8, and we end up with -4 there. So 1 take away 4 is -3. Is -8 greater than? No, it's not. So that did fail. And then it says x has got to be greater than -1, so I'll put 0. 0 plus 6 is 6. 0 plus 1 is 1. Is 6 bigger than 1? Yes. So x. So 6 is greater than 1. Yes, it did. So that's okay. So something that is not true here should fail the test, which it did, and something that is true here should pass the test, which it did. Okay, so that's the end of that exam paper, guys. Hopefully you found it useful.